Hi, in this video I'm going to be solving an example on planes. So here's the question. It asks us to find the angle between the two planes, and we are given the two equations of the two planes. I suggest you pause the video and try and solve this problem yourself, then come back and see how I solve it. Okay, so first thing, let's try and visualize this problem. Let's draw any two random planes. Say this is plane number 1. This is plane number 2. This is the normal vector of the first plane. This is the normal vector of the other plane. And this is the angle between the two planes. So think about it for a second. If you keep on increasing this angle between the two planes, the angle between the normal vectors will increase as well. If you decrease the angle between the two planes, the angle between the two normal vectors will decrease as well. Let's have a different view. So if we look at it this way, and this is the first plane, this is the second plane, this is the normal vector, and this is the angle. So if you keep on increasing this angle will increase. If you keep on decreasing this angle will decrease. And if you keep on decreasing the angle until the two planes are parallel, the two normal vectors will be parallel as well, and the angle between them will be 0. So the angle between the planes will be 0, and the angle between the normal vectors will be 0. Therefore, we're sure that if we find the angle between the two normal vectors, it's the same angle as the angle between the two planes. Okay, so how do you find the angle between the two normal vectors? Again, whenever we want to find the angle between any two vectors, we use the dot product. So let's figure out the normal vectors. If you remember, when we first introduced planes, we said that the normal vectors have components as the coefficients of the x, y, and z. So let's say this is plane 1, this is plane 2. Normal vectors for plane 1, the normal vectors will be 3, -6, -2. For plane 2, the normal vector will have the components 2, 1, and -2. These over here. Okay, so let me remind you of the definition of the dot product. Two vectors dotted together is equal to the magnitude of the first vector, magnitude of the second vector, times cosine theta, theta being the angle between the two vectors. So let's compute this. A dot b, or normal vector 1 dot with normal vector 2, is going to give us 6 minus 6 plus 4. The magnitude of the first vector is going to be 3 squared plus 6 squared plus 2 squared. The magnitude of the second vector will be 2 squared plus 1 squared plus 2 squared times cosine theta. So these cancel. We have 4 is equal to the square root of 49 times the square root of 9 cosine theta. Therefore, cosine theta is equal to 4 over 21, which means that theta is equal to cosine inverse of 4 over 21. And this is the angle between the two vectors, which is also the angle between the two planes. So if you have any questions, please let me know. Good luck.